Galloway's Tech Talk at 3, an update on the Orbit project.
So good afternoon, everyone, and welcome to Thursday's Tech Talk at 3. You've got Simone coming to talk to us about the Orbit project this afternoon. So thank you very much, Simone, and over to you.
All right, thanks. Thanks for having me back. I'm just trying to remember when I was last talking to the Tech Talk group at Galloway's. It might have been more or less a year ago, or not quite a year. Yeah. But it was quite a while ago. So Andrew asked me back to give you all an update on where we got to with the Orbit project. So that's a research project done by City University of London, where I'm based. And also it involves Microsoft Research and the University of Oxford. And I'll tell you a little bit about the project as we go on, just giving a little bit of a recap of what the project was about and then what we ended up doing. You might already know that there's a lot of cool smartphone apps already out there in terms of helping people who have who are blind or have low vision to do something. So you know, there are apps out there that recognize colors. So you take a picture of an object or something, and it tells you what color that object is, right? There's also apps that help you recognize people. So again, you can take a picture of a person and it tells you, the phone will tell you who that person is, right? So you have to tell you know, the smartphone, here's a picture of a person, and then from then on, it should actually recognize who that person is, right? There's also apps that allow you to recognize writing and even handwriting. So it'll read out what the writing says, what that handwriting says. Also there's apps that tell you the value of currency. It's perhaps less sort of like applicable over here, where currency is a bit more distinct, but in the United States, the dollar bills, all of the different value dollar bills look the same, feel the same, right? There's no distinction between whether you're pulling out a $1 bill or a $100 bill, right? There's apps that recognize how much money you got in your hand, right? It'll tell you what the currency is, the amount of currency that you're pulling out. So there's lots of stuff out there already that works on what we call computer vision, right? And one of the particular things that we were working on is object recognizers. So they are already built into apps like Seeing AI or TapTapSee. Is anybody using Seeing AI or TapTapSee?
Yeah.
Okay. Quite a few that use certainly Seeing AI, yes.
Yeah. So
Seeing AI is certainly very, very popular.
Yeah, absolutely. So you know the Scene tab on Seeing AI, that's what the object recognizers are. So they tell you, you know, you take a picture and then it tells you, oh, that sunglasses on a table, or a glass of water on a table, or my particular favorite is I took a picture of my dog sleeping in a dog bed, and it said a pile of cuddly toys. So it didn't recognize my dog at all, right, as a dog. It was just like a pile of cuddly toys. The way that these object recognizers work is that they use artificial intelligence, or AI, particularly a branch of AI called computer vision, and that uses data collected by sighted users, so images of objects collected by sighted users that are in a data set, right? And it uses that data set to train the artificial intelligence to recognize objects. So, you know, it goes through all of these pictures of mugs and glasses and dogs and so on, right? And learns to recognize what mugs look like from different angles, or what dogs look like from different angles. And so the data set that is typically used is really, really large. It's got 14 million pictures in it, right, of different objects. And that makes it quite good to allow what we call generic objects to be recognized, so mugs and you know, dogs and so on, right? The problem is that some items will not be collected by sighted people, so they never end up in a data set like that is trained for artificial intelligence, or it also won't recognize an item that belongs to you. So it won't recognize that it's your mug rather than somebody else's mug, or your wallet, not somebody else's wallet, right? And that is the particular thing that we were looking at improving. And one thing that you need to sort of understand is a little bit on how AI actually works, right? So artificial intelligence needs to be trained to recognize things. So the algorithms need to be taught what to do using these, usually a lot of examples, like of a particular object. Once you have trained the AI, you also need to check how well the AI has learned with, you know, some testing data to try it out. And it needs to be stuff it hasn't been trained on, right? Otherwise, you're sort of marking your own homework, right? It just becomes too good. And also, if the data that you train an AI with is rubbish, then the algorithm that the AI uses and that it has learned will be rubbish. So you need to have good data to train with, and you have to have testing data it hasn't seen before, right, to evaluate it with. Okay. So what the Orbit project was about was to develop what we call a teachable object recognizer, right? And by that, we mean that we want to be able to teach the AI to recognize a particular object, usually an object that is belonging to you, or something that it has difficulty recognizing because it doesn't have any kind of training data for it. So within the data set collected by sighted people, you probably wouldn't find any white canes or braille displays or anything like that that might be really important to people who are blind or low vision, right? Because they don't have these objects. So the AI will never be able to identify them unless you teach the AI to recognize them, right? So the way that a teachable object recognizer might work eventually in seeing AI is that you take a few pictures of your item, and that teaches the AI what it looks like, right? So you're generating a few items of training data. And then once it has learned that from these few examples, then the AI, like seeing AI, can identify an item as yours, right? So it hopefully can learn quite quickly to recognize that item. Okay, so the problem there is that we don't actually have a data set like that. We have these 14 million pictures collected by sighted users, but those pictures are very different from pictures that might be taken by blind people, right? Especially if they want to register an item or, you know, teach an object recognizer how it works. It also doesn't have any item in it that might be of interest to people who are blind or low vision. So the main aim of the Orbit project was really that we needed to collect a data set first to start developing a teachable object recognizer. So what that means is that we had to collect examples of objects to train the AI, and then also to test the AI with. That recognizer needs to work with a very limited amount of examples. So we don't want to use 14 million images. We want to use, say, 5 images, right? And that needs to be enough. Okay, so that was the aim of the Orbit project, to start sort of developing a teachable object recognizer, and for that we needed to collect a data set first. And when we started putting our ideas together for collecting that data set, we were thinking, well, why do we use images? Why do we use pictures? Why don't we use videos, right? And the thought behind that is that actually taking a good picture of an item is really, really hard, especially if you are blind or low vision, right? So it could be that the item is not in focus, it's out of frame, it might be blurred, the lighting conditions are not that great. So for training an AI, taking a single picture is actually really difficult. And so we thought, well, video might actually be easier for people who are blind or have low vision to capture this good data that we need to training an AI, because in a video, you have a much higher chance that the object is in the frame of the video, right? So it kind of is visible in the video. The chances of that are much higher than a single image, right? At some point, you're hoping you get a good picture of that item in a video. And that is really because a 20-second video, if you're shooting it, say, on an iPhone or a smartphone, actually contains 600 images, right? So we have a much better scope of finding a good image in a short video, right? And not only that, there's actually AI out there that can select the best images and frames out of that video. So what we decided is to switch from taking static images of items to short videos, and that's our data that we're collecting. So short video of objects or items. Okay, so in terms of the data collection, we're actually finished now with a data collection, so woohoo! We did a phase 1 in the UK only, and that was, oh God, I think that was early in the year well, it was sort of middle of the year in 2020. And that was in the UK only. Perhaps some of you have took part in that. And then in phase 2, we went global in English-speaking countries So we work quite a bit with the CNIB, so in Canada, with organizations in South Africa, in Australia, and also some in the United States, and of course over here as well. We sort of collected the data here. What we ended up asking people to collect was we wanted at least 7 videos for at least 5 objects. And those 7 videos were 2 testing videos, so things that showed the object in its natural habitat, or where you might expect to find it, in amongst other things that were around it, right? And then we also wanted 5 training videos of that object from in different locations, right? And the reason why we wanted them in different locations is that artificial intelligence is not so intelligent, right? If you provide examples of something on the same background with the same lighting conditions, it actually might learn something about the background rather than the object, right? And so we needed to change some of the setup. One of the things is that we also asked people to shoot these training videos just showing that object. And to collect the data, we developed an app to collect these videos. So it was like, you know, you just had to hit a record button, give it a name, and away you went, and it collected the video and then uploaded it to our servers. As part of that app and the whole data collection process, we also developed really detailed filming instructions of how to record the videos, right? So the way that we were putting these filming instructions together was that to get a better chance of having the object in frame, and you know, you're actually pointing the camera at it, we told people to use what we call an anchor hand, right, to aim the camera at. So you would place your hand next to the object, and you would aim the camera towards your hand, which meant that the object was hopefully also in being filmed. And then we asked people to draw back the camera. So we were using a sort of zoom out technique. And then we asked them to turn the object, right, to a different angle or perspective, and do the same thing again. So bring the camera close, zoom it back, right? And so that allowed us to get the object from various angles. So, you know, if you took a picture of an object you wanted to recognize, which wasn't sort of full on or sideways, it would still recognize it. We were getting a lot of detail when the camera is really close, but also what the object looked like, you know, from far away as you were drawing the camera back. And using that anchor hand, there was a good chance of having the object in frame. So that's the filming instructions for these training videos. As I already said, we asked people to do that in 5 different locations, and using this sort of what we call a zoom rotate filming technique. For the testing video, so we asked for 2 testing videos. We asked people to record the object amongst other objects from 2 different angles. And there we just use a sort of zoom out filming technique. So, you know, trying to recognize when you're sort of like, when you're seeing that picture. Okay, everything clear so far?
Given that you were requesting photographs over a lockdown period, obviously people are going to, was it actually a better time to collect the photos? Because I'm just thinking people had plenty of pictures, plenty of opportunities to take pictures of their own belongings, like the white cane or their electronic magnifier, things like that. Or
Yeah.
their
Yeah, I think, you know, I mean, it's really interesting. So we wanted videos rather than pictures, but
oh, that was it, videos, I remember now. Yeah,
yeah,
videos.
yeah. But you know, the point is that, you know, I think your point was, is it easier to do this in lockdown when people couldn't go out, right?
Yeah, because they'd have plenty of time, and I just wondered, you know, whether lockdown has actually helped with that, because people have obviously not been able to go out. The government said only go out once in a day, didn't they, initially? You know.
Yeah, I think we timed it slightly wrong, because now I realise we actually phase 1 was actually when lockdown was lifted. Phase 2 was during lockdown, as we went into the second lockdown.
Yeah.
So third one, depending on how you count now. But we were a bit worried about doing this data collection during lockdown, because while people might have more time on their hands and kind of go, oh, that sounds like fun, I wouldn't mind doing that. We also were hoping that people were going to give us some videos that would shoot outside of the home, right, of things that they might encounter. So, you know, we were kind of hoping, well, if you want to shoot a testing video of, say, your white cane, you know, it might be in amongst other white canes, you know, when you're going down and meeting your mates, right, or a wallet on, you know, a pub kind of table or something like that, right? Yeah. Where people would have to go out, right? Obviously that wasn't possible, but we still got good data. The other thing we were concerned about was that if we wanted to help people set this all up, or if they ran into any problems, right? Doing that support over Zoom or the phone is really difficult, right? So we had sort of a really elaborate setup of supporting people, right? We were offering phone calls, they could contact us. If something went wrong with the app, you know, we asked them to have somebody film them while something was going wrong, because, you know, when you're developing technology and the app that was fully accessible, you still have bugs, right?
You do.
Yeah, and you know, and so that was the difficult bit, actually supporting people to help to gather that data, right? Because there's always something that goes slightly wrong, right?
I think also for dealing with people with limited or no vision, certainly those with limited vision, what we perceive as individuals is so vast and far between. You might have 10 people all decided to do it with my eye condition of keratoconus or you know, macular degeneration, and none of us are seeing the same, even though we've got the same condition. And you know, so that's a huge challenge to take on board as well. So it's
and just, you know, different experience with technology. So not everybody is like a smartphone whiz, right? And so again, what we tried to do was hold sort of introduction sessions online to tell people how to use that app, talk through the filming instructions. But, you know, it probably would have been better in person. But then again, you know, it's hard to reach enough people in person as well. But it probably would have been much easier to do this you know, not during lockdown. As I said, we're finished with the data collection. What is really, really good is that we have a data set now, and we have nearly 5,000 videos.
Wow.
Of nearly 600 objects, and they were recorded by nearly 100 people who are blind and low vision, right? That, you know, that data set is the largest data set and the only data set of its kind, right? And since we've collected that, we have actually started to do what we call benchmark testing. So we used some AI, trained that up using the videos, and then tested it using the testing videos that we collected. The accuracy, so the rate of recognizing the object for what it actually is sort of between 60 to 70%, right? Wow. Which it's good, but it's not great. If you think about it, you know, a lot of these object recognizers, they need to operate at accuracy of sort of, you want probably, you know, around 90%, because otherwise it gets really annoying for people, right? So if you only have sort of, you know, 2 objects out of 3 recognized correctly, that's not great, right? So what we're trying to do is do further development on the AI to increase the accuracy and get that better, right? And that is really sort of a lot of research that needs to be done to improve that. And to really get that started, what we have done is not just, you know, we collected the data set and then, you know, Microsoft gets to, you know, try and put together an AI that works. We actually have released that data set publicly, so other researchers around the world can have a crack at it, right? And hopefully by doing that, we get to see them improving really quickly, because there is sort of like, you know, thousands of PhD students everywhere around the world trying to get, you know, compete with each other to get a really good algorithm going. So that was part of our remit anyway. So we provide that to the research community to just get better AI, right? What we're also trying to do is we're hoping to get a working version into an app soon. So because we're working with Microsoft Research, they have really good links with Seeing AI. So what we're trying to do is we're trying to, you know, get something that works reasonably well into something that you can actually use. So I can't make you any promises about, you know, oh, this will hit, you know, Seeing AI in the next month, but we're hoping to get it out in over the next sort of year or so.
That's fantastic, though, the fact that the potential there to kind of add it into an already existing app that so many people have got, as opposed to you having to download another app. It gets quite annoying because you need multiple apps to do, you know, whereas, you know, Seeing AI has got so many multifunctions, which is why so many of us actually really enjoy that particular app.
Yeah. So, you know, hopefully we get something out there for people that can be used by people like you really, really soon. So that is one thing that we're doing with our data. We might collect more data for other AI applications, so perhaps not object recognition, but perhaps something else. And we also are starting to look at, well, what kinds of objects did we end up with, right? And so we're doing some not just AI analysis of the data set, but also thinking about, well, what is it that people are trying to do with this? One of the things that I did is I pulled out the most common objects that were filmed. And I just wonder, like, if people could take any guesses as what was most commonly filmed. Do we have any takers?
Oh, let's see.
Probably your white stick.
Yeah, white canes. That was number 4.
Yeah, white cane.
iPad or tablet device. Where's that gone? Anything like me? Put it on the sofa.
Actually, we have. Hold on. Let me see. Oh, actually, that's quite far down the list.
Oh, interesting.
Phones is actually much higher in the list. We have also keyboards. Remote controls is number 2.
Obviously, it's gone down the. How did they get it when it's gone down the sofa? What about keys? House keys.
Keys is number 1. Keys is number 1. Anybody else got any idea?
I like telephone.
Telephone, yeah. Telephone was really high up. I think 1, 2, 3, 4.
Electronic
7.
magnifier.
Huh?
Electronic magnifier, because you can get portable ones, you know.
Ooh.
Not an everyday item, though, is it?
No.
Well, no, but it is something blind people might carry around,
No,
go on holiday with, for example. Read the menu in a shop.
I'm pretty sure we actually had them in there, but they're not amongst the most common ones.
Oh, right.
Wallet. What about a diary?
Sorry?
A diary?
Oh, diary. I can't see it here. That's a really good one, actually.
So go on then, Simone. Give us the top 10.
All right. The top 10 were keys, remote controls, wallets, white canes, earphones or headphones, mugs, house doors, phones, watches, backpacks, sunglasses or glasses, shoes, pills, braille displays, dog leads, keyboards, water bottles, washing machine and tumble dryers.
Oh,
how interesting.
I could understand that that's a funny one, washing machine and tumble dryer. I could understand the substance, like the cleaning stuff. Yeah, you know, the liquid that you put in them.
But if it's not just done in the UK, lots of other establishments, unlike the UK, they have both washing machine and tumble dryer side by side, and they look very similar.
Oh, that's the point. Yeah, you're right there. You're right there, Jenny. Yeah.
And also, I think one of the things that we're starting to do is sort of think about, well, why were people taking pictures of that? Is it actually to recognize washing machines versus tumble dryers, you know, what they look like? Because, I mean, it's really hard to misplace a washing machine, right? It's not like a remote control where you can slip down the side of the sofa. But what we think actually what was happening, people were trying to take a picture of the settings of the washing machine, right? So they were sort of going, oh, this is my usual washing machine setting. I want to recognize that, right? So if it's
Yeah.
if it's not on the right setting, it would tell me, right? So there was like some really interesting, there's some really interesting stuff going on with the videos and the objects that people were taking. I can also tell you that there were some more unusual items that people took videos of, or, well, not unusual, but kind of unexpected. People should have expected it. So there were actually quite a few face masks being recorded, right? Which was, you know, because it was locked down, was really interesting. Somebody took a picture of chicken instant noodles. So they were obviously very fond of them. We had a watering can. We had a Mountain Dew can. Do you know what Mountain Dew is?
Yeah.
Oh, it's awful. But, you know, obviously was really into their soda. And then we had some pictures of dog poo.
Oh, lovely. But yes, I suppose you're trying to pick up after the dog.
Well, yeah.
Exactly. And you know, I mean, the thing is that usually in, you know, if you think about the 14 million pictures that are probably, you know, collected from these sighted users, I don't think there's one picture of dog poo in them, right? So we sort of have this amazing collection of videos that, you know, we have released that are now available for other researchers, and we still sort of are doing some work to understand what is going on there, right? So lots more research to come, lots more, hopefully, apps to come. And part of the project that is now sort of closed, we're still continuing to work with Microsoft on taking that forward, obviously. And also what has become really, really clear is that people really want to learn what AI is about, right? And so what we have put together is just 3 sessions to learn about AI. If you're interested in that, you can go to our website, orbit.city.ac.uk, so orbit.city.ac.uk, and /curriculum, so CURRICULUM, and there you can find some information how to join a Google Classroom to learn a little bit more about AI, and we're hoping to develop more sessions to teach people about AI. So it's got some fun sort of exercises for you to try, and you know, gives the sort of basics of how AI works. So you can have a look there. And at that point, I think that is it. That's all I've got. So that's how far we have come with Orbit. I'm actually really pleased with it, and you know, I've learned so much.
Definitely, you should be so proud of what you've achieved, because you're disappointed with your 60 to 70% result. However, that's 60 to 70% that we didn't have prior to that, you know, and that's absolutely phenomenal, and it's a massive building block on which to develop further.
Yeah,
so it's so exciting.
And actually, I mean, what I'm most pleased about is that, you know, this involves you and your community, right? It's not it's not sort of made up data. It's not you know, thinking, oh, you know, how would a blind person take a video? It's all due to the involvement of you guys.
Most definitely, because quite often we do find that it's not quite people telling us what's needed. And it's like, actually, no, our perception of the world is very different to yours because of how we see or don't see it. So yeah, it's an amazing opportunity for us guys to have a voice. Whether the guys on the Tech Talk today have been directly involved or just anybody from around the world, it's been absolutely phenomenal. So thank you from each and every one of us, regardless where we are, as for having that opportunity and to help develop something that is going to benefit our lives quite dramatically.
Yes. Does anybody have any more questions? I'm very happy to answer.
I've just got a quick one. Are you accepting more videos?
Not for now. So the video collection is closed for now. We might do another round in the future, possibly slightly different data as well. Yeah. So watch out. You know, once we're doing something else, we'll let you know and involve you.
Our guys loved giving feedback on things and getting involved. So yeah, please do. So all I can say from this point then, Simone, is thank you so much. Please do keep us updated. I am quite sure Andrew will be in touch getting you back on to find out where we're at and things. Stuart, have you got something you wanted to ask?
I was wondering whether you had any plan to do anything with this information you've gathered about what people were interested in that surprised you, like the dog poo. Is that being passed on to anyone to get it into these systems so that, I mean, it does, now you mention it, it seems an obvious thing to want to recognize.
Yeah, so one of the things is that, you know, we have done some analysis of the data, but it was more sort of to develop the AI. But obviously there's also a question of, you know, I mean, we kind of know why people were taking videos of the dog poo, but, you know, for other things, it's not obvious why they were doing it. So what I think we want to do in future is to look through that data, pull out the surprising things and actually ask people why would anybody want to take a video of that, right? Because it's not
guide dog users are supposed to clean up, aren't they? I mean, there is lots of, you know, if you've got some vision, you know, if you've no vision, you want to know what the poo looks like, and then you can clean it up, because, you know, those who do guide dog training, I think you are encouraged to clean up after your dog.
You are encouraged to, but still by law you don't have to.
Oh, right. I thought it was a requirement, Amanda.
No, it's definitely an encouragement to endeavour to do the best you can.
But I think, you know, you know, what we're trying to identify is where does our proposed solution fall down, right? So, for example, if you want to take the setting on a washing machine, right? Object recognition, even teachable object recognition, won't be that great for it, right? You have to sort of approach it in a different way. And so what we're trying to figure out by looking through that data set is what other things do people want to do? And, you know, one of the sort of questions that I'm really interested in is what other types of AI do we want to develop in future that, you know, we can again go back to the community and get your input on.
Good, I'm glad you're not losing all this accidental extra data.
Because the thing is, you know, you're going to have your core options of, you know, the kind of keys, phones, whatever that people are after, but, you know, you might come from a different cultural background. And if you've got an app set up that's for, say, the Western world, you know, and then somebody over in the Far East is going to, well, you know, I need to know this or I need to know that. And will that app then allow the service user to teach the app itself?
So that was the whole idea about, like, you know, we want it to be teachable. So wherever you are in the world, even if it's something really unusual that, you know, I mean, you know, wouldn't be used in other cultures, or, you know, it's really unusual. You could teach the AI in a few simple videos, like say, take one video, right, of 20 seconds, and then, you know, the AI would know what it looks like, right? And then you can use it to find it, to say, is it mine or is it yours, right? So that's the whole aim of this. What we don't know is there something else that people want to do?
Yeah.
So actually, last time when I visited this group, we were talking about moldy bread identifier. Right?
Oh, yes.
Oh yeah, because it's hazardous, isn't it? It makes you ill. Moldy
Yeah, and so, you know, actually, again, I think our app would not be good at picking out moldy bread, right? Because that, you know, moldy bread can look very, very different, right? And so you probably have to do a different kind of app for that, right? And so that is really interesting, figuring out what people want, and then developing the technology for it, right? But what we need is talking to people like you to kind of go, well, what do you actually need, right? What's of interest to you, and how?
Yeah, and I know from my previous work that you can't really find out what people want by asking them what they want, because at that time they don't really know and they can't really articulate it. So it's useful to pick up this kind of information as a side effect of what you're trying to do with the video collection.
Exactly.
Yeah, so from just out of pure curiosity on the moldy bread issue then, is it possible to have the standard styles of bread, sour bread, ordinary bread, white bread, brown bread, wholemeal, recorded over time in a time lapse, and then if you took that image yourself, could it connect to the internet to find out what it was? Could it go off and find that data? To me, that's a potential amazing opportunity if it's capable of doing that. If it can't recognize the image in its data bank.
So currently no, but that's an interesting idea, right? I'm just, you know, as a sort
just
of
laughing at me now.
But, you know, actually, we were talking about it in one of our research meetings, and actually moldy bread detection is really hard, right? And so I don't think anybody has really figured out how to do it, right? Because it's sort of, how can I put it? Sighted people really don't think about it, right? And so they kind of go, it's not really a problem, is it, right? But it's really hard and obviously of great use. So I'm hoping somebody figures out how to do it.
Well, I have known, just a quick point, and I'm not mentioning names, but I have known a mother to put sandwiches ready for her son to take to school, and they replied, "Oh, that blue bread was nice to eat."
Oh.
This person had macular disease, right? This person, the mother had macular disease, and of course, she couldn't tell that it was moldy. You know, so just butters it and prepares the sandwiches just as if it was okay to eat. Yeah. And I know it sounds daft, doesn't it? But you know, it's.
But it isn't daft, David. Certainly in our community, it's a massive issue. If we've got bread that's been open a day or two in my house, the first thing I do before I open it the next time is go check that for me. Before I even open it, you can open it. You can see through the plastic packaging and have a look. You know, and it's not just bread; it's other food, but bread is the highest one on the list because the others are a little bit easier to kind of distinguish. But food in general, when it's on the turn, can be quite hard to distinguish.
Yeah. So I think, you know, I'll pitch that as a sort of research challenge at the next sort of conference I'm at. and see whether we can crack it.
Fab. So that's brilliant. Absolutely fantastic. Absolutely bang on time as well. So all we can say, Simone, is thank you so much. It's been really informative this afternoon.
Yep, thank you.
Very, very exciting things to come, and we can't wait. And if you want us to be involved in your next round of research, let us know.
Yeah, will do.
Fabulous. Thank you all very much, guys. Have a good afternoon.
Bye.
Bye.
Thank you.
Bye.
Thank you.
Bye.
Thank you.